This conference will now be recorded.
Cool. Yeah, there's some discussion around, how closely we are aligned with the other people in OCP that are actually doing hardware design, because it can be hard to separate RTU requirements from platform topology requirements, which we currently don't set in this group. So there's that topic. There's a topic which has been raised in the past. I don't know how much time I want to spend on it this time. We'll see how much time there is, but storage sanitation. Have a storage device, want to sanitize the contents on it. How do we do so trustworthily in a manner that will satisfy customers who are very uh, paranoid about data sticking around on these drives? So I have drafted basically with one of the missing pieces. I think like we need like trustworthy firmware, auditable, to give us confidence that the firmware will sanitize when asked. I think one other thing that's needed is a way to provide an attestation that sanitation has actually happened. So there's been talks about like, putting SPDM, everywhere. We put SPDM everywhere. So putting SPDM in a storage device, what does that mean? Um, well, we can have it act as an SPDM responder, reveal measurements. That's cool. That's a way to passively say, okay, I have a storage device that's running good measurements. But uh, what I think could be helpful is a way to couple attestation with the act of actually issuing an attestation instruction. So the device can say, yes, I'm signing a statement in which I'm claiming I have just done sanitation upon request. Here's a nonce. And then you can uh, plumb that through automation to make sure that only devices which prove they've actually done sanitization are released back without destruction. So that's something OCP could define. And then there's just a smattering of other topics we can shake out in our schedule. I think actually, is Chris on the call? Chris Hiller? I don't know. Um, don't see it. I have to have a quick skim. Anyways, we have ownership transfer up next week, I believe. Uh, so that'll be cool. We'll have an overview of a specification that has been put together on that. I know it's been a while since we talked about that. So, shall we talk about RTU first? Um, Matt, did you have anything you want to kind of lead with, or?
Um, I don't have anything ready to share at the moment.
Sure. Yeah, no,
Uh,
nothing to share. Yeah.
I guess the big question was really around how do you define RTU, right? What is an RTU? And I went back to the NIST 800-193 document, and it was making some really simplifying assumptions about what is a platform and what the RTU is doing on that platform. And because it was an evolution of the previous BIOS protection guidelines, it really was only looking at UFI, right? It was not considering a more complicated server platform that had a bunch of different devices of varying complexity on it, all with their own storage and firmware and other things that need to be managed and in some sense have to be managed independently. So the definition of RTU there was not particularly useful in driving requirements for building like an individual component in a server platform.
That's a theme I found in a lot of places where, like, for example, uh, uh, all language around TPMs is like, you know, and in general, root of trust, like, the platform has a TPM or a root of trust. It's like, no, the platform has dozens. Uh,
Yeah.
so,
So when I was trying to define like what is a root of trust, how could I define it in a way that was actually useful for because what we talked about, you're looking for what are requirements on sort of an individual component or device being built, right? And then these are going to be amalgamated together into a server that gets used. and I wanted to get to a definition that was potentially useful for driving requirements for a device instead of for the whole server. And that's where I sort of came back and like, hey, we probably need to discuss what is a server and what does the topology and the connectivity look like. Because when I was doing this, it sort of the answer of what do you need to do kind of depends on where you are in that topology and what assumptions you're making.
And you
So
mentioned there's also a connection here with like flashless boot, right?
right, yeah, like because I had ended up coming with, oh, hey, what if you don't have any state? Do you need an RTU or an RT-rec? The answer might be no, right? If you have no persistent state, what is there to update or recover?
Mm-hmm. But we need like the platform and device to agree on the wires needed to support that flashless boot.
Yeah, that is probably a very different discussion, but just even as far as categorizing, what are the different types of devices, what are the requirements for them, and making sure everyone's on the same page, right? I think actually defining the requirements turned out to be probably the easiest part of this, and agreeing on the definition of what is an RTU and what is it supposed to be doing, and how do you draw that box around RTU to make sure we're all in agreement on what it is and what it does, maybe a little harder. So I was I will sort of ask the rhetorical question that I had asked a couple people privately, which is, can you have more than one entity capable of updating your persistent storage and claim that you have an RTU? Because when I was thinking about this, I couldn't come up with a way where I could claim something was an RTU if more than one entity can update the storage component. Because as soon as a second entity can update it, I don't have a root of trust anymore, because things can happen out of band.
Mm-hmm.
So I was drifting towards a definition that called the RTU, the single entity responsible for managing writes to a storage component. But I hadn't gotten much farther than that.
I'm just going to throw up this document put together. This basically captures the content of the slide deck from last time. So, okay, so define RTU. Is that what you say was the your straw proposal was the sole entity responsible for?
Yeah, what I have written down here in my notes is singular entity capable of writing a storage location.
Cool. Single. That seems sensible. I think I agree that if you have like it can do something. Like, I mean, you'd have to widen your view, I think, to the whole system. It might still be safe if you have some sideband way of updating it. If the other thing if the other updater is trustworthy, but now you need to pay attention to more things.
Well, it sounds like you just need one central point where you make the decision as to whether or not this update is allowed, whether that update comes from in-band, the host, or out-of-band from a BMC, for example, really doesn't matter, right?
My concern is, right, if there are multiple parties involved, how do I, like, which one of them is telling you that the update is permissible?
None of them. I mean, it basically, the multiple parties are going to say, here's a file for updating. And then you have a single point inside the device or somewhere that says, is this file good or not, right? And if it's not good, it refuses to send it to the storage. Right?
Sure. So
what I'm concerned about is that in the server world, some people like to update from the host, and some people like to update from the BMC. So you want to allow for devices that still have support a root of trust for update without having to say things can only be updated through the host, or things can only be updated through the BMC.
But the root of trust for update for the device is part of the device in that case, right? The device is not writing its internal NVM that it stores its firmware on without that write going through an RTU.
So like
Yeah, it's part of the device, or is attached to the storage, to the storage where the update gets kept in some fashion. Yes.
Right,
so
and that's why I wanted to have the discussion about because 193 sort of defines RTU as a platform construct, and when I was doing that, I couldn't come up with a way to usefully derive like component level requirements for an SSD or something along those lines from a platform construct that just says you have to check signatures on updates.
Right. I mean, yeah. I mean, in that case, the way I'm thinking about this is that if there is a platform construct that is external to the device, there has to be a single connection. And I think that goes back to what you were saying, from that platform construct and that device, right? And if you have multiple providers of updates, they will connect to the platform thingy, right? But they can't connect directly to updates. So everybody has to go through the same place.
Yeah, there has to be a funnel somewhere, because as soon as I allow multiple paths directly into that storage device, somebody will not know what's going on and will not be in control of changes. And I don't know how you define an RTU in that case.
Yes, and you definitely don't want the device trying to figure out which of the paths is trustworthy, right? Because there's no way for the device to figure it out.
Yeah.
But are we talking about actually writing the storage, or are we talking about controlling the write? Because, I think of something, just as an example, a DMA operation where it's, I'll sniff you, and yes, if I like you, then yes, I'll let it go and you can do your thing in writing to memory. So would it not be the same there? It's a control point allowing the write, preventing the write?
I ran into similar problems so if we're talking about something where you have a write protect controlled by one entity, but the actual data being provided by another.
Yes, yeah.
I don't think you call the entity in control of the write protect an RTU, because it still doesn't have any knowledge of what data is going on to the storage, right? Something has to check the data before putting it into the storage.
But it depends. What if the storage is a staging area? For ingestion of an update, right? You're checking before or after. I guess as a signature verification, I think
I'm only concerned
makes
about
sense.
data that's actually going to be used.
right,
Like the staging area is sort of immaterial in my view.
Well, how do you land the update into a device?
you can put it in the staging area, but like we don't need to say like
Well,
only
the
the
definition here is the device is capable of arbitrating writes to a storage location.
Something is capable of arbitrating writes to a storage location. May or may not be the device, but something.
Okay.
Right? Like I'm defining RTU here in relation to the storage, not necessarily in relation. That's the catch, right? This says an RTU exists in relation to the storage, not necessarily the device. And that's where I started asking Jeff about all the topology questions.
Matt,
Yeah.
so like just the point of that staging area, like to a storage location, the staging area need not be arbitrarily regarded by RTU. It can be read by RTU, and RTU can say, oh, you staged something, cool, let me take a look at it, validate signature, and then copy it into the actual storage location that I care about.
Is it really the write, or is it activating the storage location?
So you're talking about something where there's like essentially multiple banks of storage,
Yes.
and only one active and some fallback. That's an excellent question. I don't know.
But do you arbitrate the rights? It's a little bit more nuanced. Do you arbitrate the rights, or do you arbitrate the consumption of the update?
Yeah, that's why I said activate. That you can do all kinds of things, but the RTU is the one that makes the final decision as to whether to make it live or not, or it's okay or not.
Is this
And
You know,
that might help solve the dilemma of um, that single entity. If there's multiple paths, um, there's one mechanism. Like there's multiple paths to getting content into storage. Um, like there's usually multiple paths to write. You could write over JTAG, you could write in band, you could write out of band, but the activation should have a single flow. And I get the nuance around platform, device. What is a platform? Is does a single device constitute a platform? It could. Um,
sure? Like your device could be your motherboard.
yeah, yeah. So like it's how do you like staying out of the architecture is probably wise for the requirements. Like unless we have to go there, like avoid the topology on it. And I think getting down the at least the requirements initially, um, and the definition of what the RTU should be.
Does this, the way we've massaged this language, this pretty good as is, or I think it still needs some work? I guess.
I
Matt, what
would,
do you?
I probably would get rid of the within a device words. And maybe
yeah,
to
that's
storage
true.
location used by the device.
Yeah, that's better.
Yes, I like that. So BMC can be RTU for some other device, or
Right.
something. The device can
Yep.
act as RTU for it. I think this sentence is helpful, pulling its weight.
What's an AP? Oh, AP is right there. Application processor. Silly.
Probably useful. I'm still trying to weigh the difference between activation and rights, and I'm not.
Mm.
I'll
Yeah,
I'll go back and look at this afterwards. I might try and wordsmith this a little.
I tried to elide over that, but just saying it updates the sort of location. So whether you're writing or activating is kind of an
Yeah.
implementation. We could provide some informative text saying, you could do this by just guarding rights, or you could do it by having some staging areas. You could activate the staging area instead of copying. A lot of ways you could do it.
As far as the second sentence with corruption, when I read the word corruption, I'm thinking of bit flips and accidental things, which it does need to do. But then there's also, yeah, it's
You could use the word integrity, just protects, guarantees the integrity of code or configuration. I mean, um,
yeah.
I'm thinking probably in the table you just leave RTU as root of trust for update. Maybe have a separate paragraph explaining all this.
Oh, sure. Yeah. I don't know if I need this sentence here to be.
Yeah. Or just, yeah.
Well, hang on. Integrity
Maybe don't
is,
feel constrained by the table.
Right. Yeah.
and integrity is good for corruption and such, but it's then you get into authenticity, right? Because if it came from the wrong place, the signature's bad. Yeah.
Of course, if you have authenticity, you have integrity, so could just do that.
Not necessarily. I'd put integrity back. It depends on the algorithm.
Yeah, you probably want to add a pointer in the table to the definition and scope. Yeah, in case the table becomes big.
Okay. Now, I have in the notes of the presentation that when we talked about A/B updates, which is kind of gets into the whole activation discussion, we decided we only need it if the AP is not a symbiont device, and I'm afraid I can't recall the nuances of that discussion. Symbiont device as in something which can be recovered from a different device.
Yeah, that's the 800.193 defined the symbiont as something that relies on an external agent on the platform to assist it, essentially. I think they have a better definition than that. We can probably go back to it. But this was the other part of the discussion is there are several different types of devices based on whether they have local storage to be updated in the first place, whether they require help from something external for parts of their process, or whether they have to be truly autonomous.
Mm-hmm.
Maybe there are other classes too, but those were sort of the three that I was able to come up with.
But even if it is a symbiont device, it could have an AB
You could, but I would
mechanism.
argue that it's not required, right?
Oh, I see,
If
because you got
well,
requirements. Okay, sorry.
yeah. So, or maybe I should be more specific. If you have a symbiont device with recovery, and I would argue that recovery is probably a requirement for a symbiont device, but maybe out of scope of an RTU requirement. If you have a symbiont device with recovery, I would argue you don't need AB updates because your fallback plan there is just do recovery. But that's why I was trying to figure out like what are the sort of types of different devices for which we would be concerned about an RTU, because I think the requirements differ a bit for different types of devices depending on those assumptions.
Okay. These are the high-level categories of requirements. I'm going to bump down the zoom level a little bit just to make room. We could add or remove these, but these are the initial steps. So signed updates, code updates have to be signed. Doesn't say by whom. Ownership transfer is a sub requirement. Allows the owner to manage the keys which validate these updates. We have anti-rollback. So we have to support some enforcement of anti-rollback, but we must allow some limited, we can't just be point of no return. Once you get to version 5, you can't go back to 4 because rollout practices often require the ability to always roll back to the prior version. I added a link to the Calyptra spec. I'm just going to share that real quick. This is some language that we've added to explain how two numbers, the SVN and the min SVN, can work together to allow these kind of limited rollouts, rollout windows. We don't need to, I mean, that link, I guess, is useful for review. We can kind of crib this language and put it into the RTU spec where it belongs instead of calling out to Calyptra in the final version.
Would it be worth articulating that the rollback should be an independent process from the update, so the rollback isn't automatic in the update, that you can do the update and then you could affect the rollback separately?
I've always considered it like a rollback as just an update where your version number happens to be lower than your current.
Right. So I guess that lock in. So for example, you update a particular piece of firmware, and you don't want to lock in the rollback while you validate that that update doesn't break your environment. And then when you're happy with it, then you can lock it in, so that it's not an automatic thing that I've done an update and it automatically will block me.
Oh yes, exactly. That's
the updating of min SVN should be independent.
So the mechanism, basically, yes, we need a way to update to ratchet min SVN. That's the number which actually says you can't go any lower than this, and it is independent of the actual SVN of the firmware image. The way Calyptra has framed it here, these are two numbers that appear in a signed header of a firmware image, and so basically we get kind of like authentication of min SVN for free, because we just tuck it into the firmware image. So like updating min SVN is done with a firmware update. And the firmware update could have the exact same SVN and the exact same image as the other one, just you've ratcheted min SVN forward.
So in that case, you're forcing the update process to update min SVN. You're just now have two images.
Exactly. An alternative scheme could, we could come up with a separate framing for here's a signed message which doesn't have any firmware, it just has a min SVN and it is a directive to update min SVN to this value.
Okay.
I think that could be made to work. I don't see any reason why not. And
okay. Well, okay. Yeah, I think it would be good to not articulate the how, but just the requirement.
Okay, that's good.
We've done the second one in client side. I don't know if it's done in server side, but in clients we've done exactly that. It's been a separate sort of signed message that rolls up the min SVN. But yeah, I just think stating that you need to separate those and don't force an update, or don't have a scenario where you can do an update and not ratchet the min SVN.
I know it needs a special flow then, right? If you separate them, like for anti-rollback, you need a rollback of the min SVN too. So there's a nicety in making it one flow, as it's less work to do. When you separate them, it's a little bit more work.
Well, I think that the problem, you wouldn't ever want to roll back min SVN. That sounds like
and the device wouldn't let you. It would just say no. But I'm imagining, like, I'm just thinking out loud here, the way we might want to operationalize this if we got a device which had them be two separate, we just have our regular firmware update scripts go, okay, flash the firmware image and also this other special ride along file, send that over as an auxiliary command. Just do that every update. So, and then we would have the freedom to, manage those files independently, but we're not forced to do it independently. We can have it all be part of the same flow. But from the device's perspective, it's two separate events.
Yeah, I would. Yeah, I didn't want to get hung up on the how. Just that you'd want to have some ability to be able to do an update and then back it back off before you ratchet it in.
Brian, did that make sense? Or like, do you feel like we should maybe think more about whether this really needs to be part of the image or whether we can handle them being separately? I think we can handle them being separately, but
The header is separate anyway. So yeah, if you have a separate signed header, and the firmware is just a digest in the header, you decouple them both.
yeah, could do that.
Yeah.
Say, hey, I don't actually have any firmware with me, but here's the rest of it. Go do the thing.
Yeah, here's my header. You've already got the firmware. You're doing two copies of the header, right?
Mm-hmm.
Identical except for the SVN number.
Yep. Min SVN number. Yeah.
Yeah, min SVN.
Okay. Cool.
Okay.
So we can flush that out. Good comment. Thank you. Okay. AB updates. I think I'm not sure what to say here beyond support them. We could say at least 2 banks. We don't need to say only 2.
Are you back on the other document?
Oh, I'm sorry. Thank you. Thank you for that.
So with AB images, if you have those mechanisms and you don't have a good recovery mechanism, and you can do great work on integrity of your AB and making sure that you only ever accept a good B if you booted from A, so you have a good A, all that kind of work. But if you have a key compromise, your device, the A and B can be compromised.
Like as in the key that signed my images has
Yeah.
been compromised.
Yeah.
Yep.
It's like a gap.
So recoveries, yeah, I think recovery would help you address that by just saying the device. We're not going to say the device is the only thing responsible for validating signatures.
Yeah, A and B updates also have some problematic interactions with anti-rollback in that you may assume that you have 2 valid images, but as soon as you install an image into a slot that has the anti-rollback, a min SVN greater than what is in the other slot is effectively gone. So it's not necessarily that is a design property, but people may feel that there is a level of resiliency that is not in fact there when you combine the 2 features.
That's a good point. I think we need to require that. So I have some sections here, some sub bullets. So one of them is reconciliation of A and B halves. So we should, after you do the update, have them be the same. And I think we should say only ratchet min SVN A and B are sent.
Do you want to? I feel like A and B updates is a specific implementation of having some kind of fallback image, and I'm not sure if you necessarily want to call out one specific flavor. Like, there's other ways of providing a fallback image and dealing with these things. I think the min SVN issue is relevant regardless, but I don't know if you want to require specific implementation of how to deal with having a fallback image in case your currently active image doesn't boot.
Yeah. Do you have, just for sake of discussion, do you have any like specifics in mind of like alternatives? I mean, like golden image or more than
Uh,
two, or
yeah, I was going to say there's golden images, but I've seen schemes that don't strictly have like A B that you ping pong between, right? There's you can have active and backup that are fixed position. Like there's just slightly different ways of doing it. I think people are going to interpret when you say A B, they're going to interpret some specific meaning there that I don't necessarily think.
maybe we need a definition. Okay, we need to define it here.
Yeah, what I keep wondering is there's definitely a dependency between the update and the recovery when it comes down to things like this. So I wonder if there should be a section in the spec here that sort of talks about expected interactions between update and recovery, and then AB could go in there, right? As this is one way of doing things, that kind of stuff.
I'm sorry, I missed that.
Yeah, no, I was saying that there is this dependency between RTU and RTREC,
Yes.
right?
Mm-hmm.
And every time AB comes up, I tend to think that this is sort of RTREC's thing, right? To use the AB stuff, but to put images in the A and the B is sort of RTU, right? Because you have to make sure that they're protected and all that good stuff. So I wonder if there should be a section here where we discuss the interactions between RTU and RTREC, and then in that section we can talk about A and B or shipping a special recovery image with updates. I don't know, something like that.
Yes, I do have. So I think that makes sense. I've added this header to fill in. So yeah, we do have this language where if you do support recovery, like if there's an RT rec watching over you, you don't necessarily need to support fallback images, because someone
Right.
else like give you your image whenever.
Assuming that you can guarantee that there will be something there,
Yes,
right? Like it's possible to have a component which could be used in places where it would have a platform agent to drive RTREC for it, but it could also be used in places where it might not.
yes. So that would probably be. You think that's captured by a symbiont device? Like it might be a symbiont device, or it might not be. And if it's not, then you must support fallback.
Yeah.
I mean, it would be neat if we can range it so like there actually is no interaction between fallback images, which I've just renamed from AB, and RTREC, because if you have RTREC, then you don't need fallback, and if you have fallback, yeah, mutually exclusive. I don't know if that's aiming too high.
I'm confused because I thought RT-REC was when you just had the bare minimum left. That it was, all you could do is essentially check signatures and boot. Then it didn't have all of the updates and so forth.
The way I've seen it is, or the way I think about it is RTREC gets involved when you can't boot for some reason, right? And then how and what you do depends on what kind of mechanism you have to support. It could be a minimal image that allows you to do a download of some other image or something like that, right? Or it could be simply switching from A to B. But I mean, but that's the problem is I haven't found a definitive, this is what RTREC is, right? There's this close interactions between it and RTU, and it's hard to separate them.
Yeah, I agree.
Okay. So I'll put a pin in that. Now I added this phrase around persistent regions. Some of our devices support this, where the flash layout has areas that hold logs or other pieces of data which are expected to survive across updates, and special consideration would need to be made if you're doing fallback to preserve those regions. That could be. As I'm saying this, I'm wondering if this even needs to be a requirement, because if your device supports persistent regions like that, and you also support fallback, you've kind of shipped a broken product if you don't support them both in a seamless way.
And you're viewing these regions that you could have anything in them. Like, would you have keys in there?
So that's a good question. It's like the way the implementations we've seen of this, it's kind of up to the device to manage, and ergo, it's very hard to put any kind of authentication requirements on whatever's there, because who knows? It could be some logs or other random data. It is useful to have some kind of sanitation flow and say, hey, whatever's in that thing, scrub it, because we need to move it to a new customer.
So I guess the question here is, so just because there's storage doesn't mean the entire storage is governed by the RTU, I think is what you're getting at here.
Yes, and it might be
And
commingled.
so there's a set of things that are device specific that must be protected by the RTU, and then there's other stuff. I don't know that we can or want to put requirements on how that other stuff is managed, because there's consequences of doing that.
Yeah, perhaps. We could say, like, we're not going to put any requirements on how that extra storage is managed, except that the device provides a means to sanitize it on demand.
I'm not even sure you can require that.
Yeah, is that specific to updates is the question, right? Which
Right.
No,
I don't
not.
think it is. I think it's what Matt was saying. So
And
we just
I
keep
think,
that out altogether.
yeah, I think the part here is we're saying there's a set of code configuration data, like whatever. There's some segment where we are guarding it with the RTU, and then there's other. And I don't think we can really say anything about the usage or behavior of other here.
Mm-hmm. Okay, so separating it out from RTU, like let's. I think I agree. We should get rid of it in part of this discussion for RTU. I do think it would be useful if there are devices which are storing like logs or other pieces of data in their persistent storage. It is nice to be able to run it through a flow and say, you know what, we're decommissioning this device. I want all that data gone. Device, please clean yourself up. So possibly a separate discussion, but I think it would be a useful ability for devices to support that where it makes sense.
It's like a special
Yeah,
update.
absolutely, and that seems to be part of the ownership in a way, right? Ownership transfer and so on.
Possibly, although ownership transfer is really like the way we're framing it here in OCP is I'm handing you over to a new person who's allowed to tell you to do things. Here's the new signing key. Whereas this sanitation is like, I still own you. I just want you to clean yourself up. They can be orthogonal. You could follow that up with, okay, now you're clean, and now I'm going to hand you over to someone else.
Yeah, I mean that the second one you talked about seems to be very device specific to me, and I'm not sure if we can get into defining what that is for. If you take an FPGA on one side and then you take an SSD on the other side, it's probably really difficult to find something, describe exactly what that is.
Yes, actually, that makes me think we might be able to solve that in one go with the SPDM command that I mentioned in the beginning of this call, which we can talk about some other week. Cool. All right, gone.
So, yeah, I was going to say for the for SSDs, there will be things where you don't actually want to erase, right? For example, bad block information you probably don't want to erase, even when you're decommissioning a device to pass it on to somebody else.
Okay, cool. We can have a discussion about that, I'm sure. Successful boot notification. So in implementations where you have more than one copy of the image internally, it's useful to be able to tell, for the AP to tell the RTU, you just updated me. You have two halves, or however many copies internally, and they are currently inconsistent because you need both the old and the new. RTU, I have booted the new image successfully, so you can now proceed to make the two images consistent. So it might be useful to define a standard framing for that, possibly in terms of PLDM firmware updates.
I'm struggling to reconcile the way this is worded with what we agreed on as the definition of an RTU earlier, because I think this is not the RTU doing this part anymore.
Okay. Is this issue with the successful boot notification or the concept of fallback images?
No. I think with the fact that successful boot notification is saying the RTU must expose something, I think you're looking at device behavior, but not necessarily RTU. Device behavior on boot, not necessarily RTU behavior, given the previous definition of RTU.
You certainly want to have some kind
The
of
RTU is not
notification. Yeah, you do need a notification mechanism for letting something know that you've done the update, but the question is whether you keep going and try to boot it and do more than that is, I think, in question.
How's that?
Do you think it would necessarily boot it to know that it's okay?
What? Sorry, could you rephrase that?
Does it have to boot it to know that it is okay?
I think that's that one of the purposes of having multiple images is it might be cryptographically valid, but it also might crash immediately. And if it does, and that's all I have in Flash, I've now bricked the part.
And is that, so I think Matt's question is that a function of update or something else?
Yeah, I tend to see that as part of the RT-Rec, right? The update just puts the thing there and makes sure that it's that the integrity of that image that is loading is where it's supposed to be, integrity and authenticity and all that stuff, right? And then this kind of notifications and things are more specific to recovery.
So we defined RTU as the only entity that can manage storage, or a storage location, right? If that storage location has multiple copies of the firmware, then things like, I feel like the RTU needs to be involved in this if we're going to reconcile those images after a boot.
So yeah, that's interesting. I mean, you can look at it two different ways, right? One is you can say there's a storage location that has multiple images that can host multiple images, and the RTU has to be concerned about that. Or you can say there is one image, and then where that image goes into the storage location is what the RTU is concerned about, right? And then if there are multiple images and you have to manage them and boot from one or the other or that kind of stuff, that's something else. It's not necessarily the RTU.
I think what I'm hearing, let me try and rephrase what I'm hearing. The RTU, the choice about how to boot and which image to boot from would be like the RT-Rec or something else. And then actually changing the images on the storage would be the RTU. think I agree that like this is not strictly just the RTU, right? Because the RTU is
Right.
not involved in picking which image to boot from.
Right.
But if you do successfully boot, then you have to make sure that you do have to, after booting, go back to the RTU and make sure to reconcile if you have differences there.
Or yeah, this is where this RTU RTREC interactions come in.
Yeah.
And
Yeah, I mean,
yeah,
you could stop at the point of saying, I've verified integrity and authenticity. I know those things. I've put it here. It's safe. It's good. And something else, go decide if it's the image that you wanted to have. You protect it against rollback, but how do you know what is the right image?
So there's now a very close coupling between RTREC and RTU.
Yeah.
I mean,
a situation you definitely would want to avoid is, let's say you had slots for 5 different firmware versions. If you overwrote them all, and then it turns out none of the ones you just wrote worked, I mean, you have to avoid it. But I mean,
yeah.
that's technically not the RTU's job, but you would want to try to avoid that scenario.
And yeah, and like let's, I mean, if the RTU and RTREC are not like authenticating each other or have some means of understanding that only the RTREC can say certain things, like the RTU, I could tell the RTU, listen, here's a signed update, stage it, do exactly what you said, stage it to all your slots, and now, yeah, they're all valid, but the RTREC can no longer do its job of managing fallback images because I've just overwrote them all.
Right. It sounds like something like the RTU says, here's a good image that I can place in storage, right? And in this case, the RTREC would say where in the storage you put that image.
The
The
RTA
problem is
would
that
also be responsible to verify that it didn't violate the anti-rollback.
Yeah. I mean, this sounds like these are two different roles that the same device would have to provide.
And they'd almost have to interact with one another
yeah.
directly.
Yeah.
Yeah, I've always had a very hard time seeing them independently from each other, right?
And we have this holy grail where like update and recovery are just the same action. It's very simple to reason about. I don't know. Is it? What if we didn't
I mean, I
have
guess it's all about terminology because, like recovery could mean, okay, all my flash has been hosed, and what's my fallback, to some just fundamental fallback. Or, then there's a question of managing multiple images. And so, I don't know, maybe there's more than one root of trust for recovery, or something. And, maybe we shouldn't get hung up on that term and that there's only one of them, something like that. Because, it seems like kind of
Well,
imagine different scenarios.
yeah, and one way that I think is useful, at least for me to think about, is to say, well, the RTU job is sort of straightforward and it applies to all kinds of different devices and that kind of stuff, right? The RTREC job is very specific to how the platform is put together, right? There's all kinds of dependencies and stuff, and it's much more difficult to generalize it, right? Other than saying you have to ensure that if there's a failure booting, that you can recover the device.
I think there's also different constraints on, or different expectations about those mechanisms. For example, a hyperscaler would expect that the RTU be relatively quick, a fast process for applying it because it's the common case. Whereas recovery is a thing that should not happen in a well-designed system. It's something's gone wrong by that point. Therefore, we might be willing to accept a much slower, much more tedious path to bring the system back to a working state, as long as that slow path was not the common case.
in that case, I think this whole fallback image reconciliation stuff would have to be part of the fast path because that happens on every update. That's just regular business. Interesting. Okay, so it sounds like we need to do some noodling on some Venn diagramming here. Where do their roles begin and end? But we are at time, pretty much. So great discussion, everyone. Thank you.
Thanks a lot, Jeff.
Yes, as mentioned, next week we have ownership transfer from Keir Hillier. And yeah,
Brilliant.
catch you then.
All right. Thanks a lot.
Thank you.